Okay, so hello, today we'll be learning about the basics of Git and GitHub. So, first of all, okay, no, let's not start here, let's start here. So, basically, if you like broadly speaking, we are going to talk about two things like Git and GitHub. So, like, what's the difference and also basically Git. First, let's talk about Git. So, Git is a technology, is a version tracking technology. Like this is a keyword here. It's a version tracking technology. So basically, what happens is ki when you are working in a project or something, or we're working in a collaborative environment where to the same code base we can have 12 people, 20 people, thousands of people collaborating, because to build or develop an app or a software, a piece of code, you can't just have input from one single source. Like someone might be good at something, other person might be good at something, so you have to factor in all those people in such a way that if a single person makes a change, it does not affect or break the code of the other person, and so on. So for all these things we have things like Git and GitHub. So basically what happens is when you are building an app, what happens is that, for example, you built an app, it's very stable, runs perfectly fine. Now someday you realize that you need to add a new feature to the app. Let's call it feature 1. Okay, so you realize you need to add a feature 1. Now there are two ways how you can approach this. So there has to, you'll have the, for example, you have the code for the app in your local. Okay, right now it's a local app. So what you can do is just navigate to the code base in your local system and start making changes to that. But the issue with that is, for example, if your code breaks after you update your code with this feature 1, so what are you going to do? Are you going to revert back? And the whole duration while you're working on this feature 1, your app would be unusable now, right? Because you're updating the code. Once you finish updating your code with feature 1, either the code will run perfectly with feature 1 or it will break. Okay, so I need a system where I can track changes I make. I can create something called as branches. Basically, if I want to work on a new feature, I create a copy of my code, I create a new branch and work on that separately. It does not affect my base branch, so my app runs as it is, and my feature, I can also work on that simultaneously. Okay, so you get that now. For example, I have a food delivery app and it has a master code base. Now if I want to implement, for example, a new map in the app, like you see now the delivery partner, he's when he delivers to your location, you see a map. If I want to implement a new map, I won't start directly editing the base code base, obviously, because I can't risk breaking the code. So what I'll do, I'll create a new branch, and once I create a new branch, then I'll work on that feature in that branch, and I'll not touch the original code base. That will run as it is. I'll test my code in the branch. Once it runs perfectly fine, then I'll merge these two branches into one and my feature will be implemented. So this version tracking technology is known as Git, and Git is like open source. So basically this technology is something that anyone can have in their local system. Okay, so like for example, if I fire up my terminal, so here if I type git, you can see that I have git here, right? So like I have the git terminal version. So for example, if you're on Windows or on, so you can basically just head over to their website and you can even download git. Okay, so you can like have it for Windows, for Mac, for Linux. Okay, so for example, for Windows you'll have to download the installer and all and set it up. Okay, so now, okay, let's start very basic. Let's start with creating a folder. Okay, so how do we create a folder? So like for example, right now we are inside my base directory, so let's create a folder there, mkdir, and we are gonna name this folder as Git and GitHub. Okay, makes sense. Now we are gonna move into that folder. Okay, so now as you can see, we have this is the folder. Now to start using Git, we need to initialize our folder as a repository. So what is a repository? It's nothing, it's just a directory or a folder, but in terms of Git, in the Git world, we call it a repo or a repository. So first things first, what I need to do is initialize this folder as a GitHub, not a GitHub, sorry, GitHub we'll cover later in the video, as a Git repository. Okay, and you'll basically understand the difference between Git and GitHub. These are not the same things. So how do I initialize my repository as a Git repo? The command is simple: git init dot. So basically git is basically like I'm telling it to use Git. Init means initialize, and dot means basically initialize this current folder as a Git repo. Okay, so when I press enter, like this has been, so like you can see here, initialized empty Git repository in home hypercool GitHub like so. Okay, so what happens now, like you don't see any change here. Okay, but actually there has been a change. If you look into this folder now, you can see we have a .git folder. Okay, so why is it not visible here? Because it's a hidden folder. Okay, if I enable the like show hidden folders option, see, you can see it's a .git. So what this .git is storing, so it stores branches. What are all the branches that are available in this Git repo? What are all the basically the history of all the changes you have made, all the changes that you are basically. The very reason we are able to use Git is because of this folder. So you can revert back changes, you can merge branches, you can create new branches, you can commit changes, you can push changes from different sources. All this is possible only because of this Git folder. So bear in mind, this folder is very important, and there is a reason for it to be hidden, so that you can't just directly go in and edit that folder. Like you should not be editing that folder at all. So yeah, that's what how you initialize a Git repo. Okay, so first steps first. Okay, we're done with that. Now before doing anything, what we should have in our folder is a file. Obviously we should have a file, so let's create a file. Let's create a file named tute.txt. okay, let's type something in that. Hi there everyone, hope to see you all soon. Okay, so now we've created this file. Let's save it. Yes. If you look into the folder, yeah, you'll see a file. Like for here's my folder. We have a tute.txt file created. Okay, so now what? So basically, whenever we make a change, basically creating a file is a change, editing a file is a change, deleting a file is a change, renaming a file is a change, moving a file around in the directory is a change. So whenever we make a change, we need to tell Git that these are the changes. Okay, and like add them to the history that you are maintaining. So basically what happens is, now a very good example like someone gave me for this was okay, so when you attend a marriage, what you see there, like, there's a bride and there's a groom, and basically you move to the stage to gift them something, and then the cameraman will basically click your photo. He'll click the whole photo. So what was the step before the clicking of the picture? You moved to the stage. So basically what Git does is it keeps a track of what are the changes that are being made in the Git repo. So if I type git status, you see it tells me on the branch master. By the way, by default, when you initialize a Git repository, it'll create a default branch for you known as master. You can see it here also. Like, this is my username, hypercool. This is the folder we are in, GitHub, and this is master. This master means the current branch I am in. If I change the branch I am in right now, this master will change. Like for example, if I may create a new branch named branch 1, so this will change to branch 1. Okay, so I can do that also, and this is obviously the time. So when I type git status, what it tells me, no commits yet. We'll talk about what commits are in a minute. Untracked files, basically tut.txt, the file we added right now, it's untracked. What does that mean? That means that right now Git is not tracking this file or the changes that are taking place in this file, because you haven't basically told Git to explicitly do that. Now how do we do that? How do we tell Git to basically track this particular file? So just like the marriage example, first you move on to a stage. So Git has a staging area. Basically any change that you make is first moved onto the staging area. Let's come back here. So I make a change, and then sorry for the spelling mistakes. I make a change, then that change moves to the staging area if I want it to. If I don't want it to move to the staging area, it's my personal wish, but a change will be made, it will be moved to the staging area, and then it will be committed. Now what is this commit? So basically the cameraman, he's taking the picture, that is a commit. So what is the purpose of picture? It's capturing a snapshot. Okay, it's capturing a memory. Similarly, Git is capturing this change and logging it in its history. For example, you made a change in your code, you staged it, then you committed it. Now if you want to revert back, if you have not committed a change, Git cannot help you revert back. To revert back changes, to keep a track of all the changes, to keep a track of who all are making those changes, who is the author of that particular change. You can even track it line by line, like who's changing this line, which user is changing that line. If you want all those functionalities, you need to commit your changes. Okay, commit is just taking a snapshot of that change and logging that in Git's history. So now first step, how do we stage a change? We made a change, we created a file named tut.txt, we added some text in it. Now to stage a change, you can simply type git add and the name of the file, tut.txt. Okay, or what you can do is, like, if you want to just add tut.txt to the staging area, you can type this. If you want to add all files that are untracked at the moment to the staging area, you can just add git add dot, sorry, it's not GTA, it's git. Like generally you'll see people doing git add dot. So what it does it will basically add all untracked files to the staging area. So for example, right here we had just tut.txt to add to the staging area. For example, you add 15 files, so you won't write every file's name in front of git add file 1, file 2, file 3. To prevent that, we do something simple. We just write git add dot, and this works perfectly fine. So when I press enter, now if you again do a git status, you can see on branch master there are still no commits, but there are changes to be committed. This means people have arrived. People in this case are obviously changes, like in the marriage example. So people have now arrived to the stage. Now you can click a picture, you can take a snapshot. So basically this now turns green. So new file created, tut.txt. So this change has been staged. Now what was the next step after staging? Committing. So now we're going to commit this change. How do we do that? Git commit. Like the commands are very intuitive. If you want to stage, just git add, or if you want to commit, git commit. If you want to check the status, git status. So it's very simple. So git commit, -m. Now what is this -m? It's basically a flag which tells Git that this is the message I am going to type along with this commit. Like for example, every change that you commit, you want to have a description of that commit, so that when someone else looks into your code base, he can basically tell ki this particular user on this day in this file he made this change, and he can basically read that description and tell ki acha, that was the commit that was taking place. So if you type git commit -m and for a message, like it's your choice, whatever the message you want. So for example, my message would be created new file tut.txt. okay, it can be anything, but it should be something useful which can help other people or you yourself track your changes. Okay, so like for example, if you want to revert back to some commit in the future, this description would be very helpful. Okay, so now if I click enter, master root commit created new file tut.txt, one file change, 3 insertions. By the way, why 3 insertions? Basically this means that 3 lines of code were added, and if you remember, we had 3 lines of code in our tut.txt. The first line, then a space like the enter, and then another line. Now if we do git status, see on branch master, nothing to commit, working tree clean. This means that this particular change that was staged, it has been committed, so it does not, now git does not have anything else to commit. Okay, so now when you see this particular message, it means that all the changes that you have made have been committed, and if something has been committed, means it was already added. You can't commit without adding something to the staging area. Okay, now this, you can keep doing this, like you can keep making changes to the folder like this. You can keep adding new files, you can exist this particular file. Okay, for example, if I move into this file, I just add 2 more exclamation marks here and I save this file, close it. Now what do you expect to see when I type git status? Modified tut.txt. So now git has tracked this change, that we have modified a file named tut.txt. So again, if you want to commit these changes, simple, type git add dot. If I do git status now, modified tut.txt, so this change has been staged. Now if I want to commit, git commit. Now I want to created new file, I would do something useful like modified file tut.txt. okay, committed, git status, nothing to commit, working tree clean. Okay, because this change has been committed. Okay, so now we can keep doing this as long as we want, obviously, but everything we are doing right now is in our local, stays in our local. Okay, now earlier I talked about like collaboration and all. So how do we achieve that? So basically there was like for example, you might have heard of GitHub. Now what is GitHub and what's the difference between Git and GitHub? So Git is a technology that enables version controlling, just like we talked earlier. GitHub is a platform where you can create remote repositories. What do I mean by that? For example, this particular folder is in your local system, no one else can access it. But like think about this, for example, if this system was remote, it was somewhere in the cloud, and everyone could make changes in their local and commit to the cloud directly. Won't that be fun? Because then like for example, if 4 people are working on a project, everyone commits and all these changes are shown in the master code base. Okay, because right now only you can work on this local folder, but if you want collaboration and things like that, you use platforms like GitHub. Okay, now mind it, GitHub is not the only platform that does this. You have Git Labs also. Okay, like you have many platforms. So basically you are not limited to GitHub. You can have a plethora of platforms. The only thing that remains constant is this Git technology. Okay, so this technology won't change. The platform you're using for collaboration or to create remote repositories, that can change. Okay, so that, for example, in our case we are using GitHub. So many people are confused between Git and GitHub. They feel that they're the same thing. They're not the same thing. Git is a technology, can be implemented in your local. GitHub, on the other hand, is a platform for creating remote repositories. So just visit https github.com, create an account and all, and here you'll see top repositories and create a new one. So we are going to create a new repository. So basically what we're going to do, we're going to, this folder git a github, we're going to push it to the remote repository. Okay, and like we're going to make changes in our local here, and we're going to push changes, and we're going to see live those changes are going to happen in the remote. And similarly we're going to make changes in the remote, and we're going to pull changes, and on a live basis we're going to see changes taking place in our local. Okay, so first step, visit github.com, create an account, and click this new. Basically this is for creating a new remote repository. Okay, so when I click this new, create a new repository, no template, I don't need a template. This is my name, Relatrino code owner, repository name, so I can name it anything. It does not have to be same as this, mind it. Okay, in my case I'll name it same, the same thing, but no, it does not have to be the same. Git a GitHub. Description, you can add it, it's optional, but basically it helps people who are accessing your repository to get an idea of what the repository is about. Public or private, it's your choice. Like you can make the repository public, anyone on the internet can access it. Obviously anyone on the internet cannot change the files, but anyone on the internet can view them. And private is that no one can even view the files. Add a readme file, no. Add git ignore. Okay, so for example, when you're working with certain projects, you don't want certain files or folders to be committed or to be staged any time. Like for example, when you work with Node, you don't want the Node modules to be committed, because those files are different for different, like they're, first of all, they're very heavy, and second of all, they can be generated by anyone on their system. So you don't want some files to be committed. Like it can be a personal reason too. You don't want a file to be committed to the remote repo. So what you can do, you can create a .git ignore file and add those files in this, add the names of those files in this git ignore file, and Git will never basically commit them or basically push them to the remote repo. Add a license, yeah, you can choose from a various list of licenses. Basically license is, for example, if you're creating a software, so you need a license basically on copyright and things like that. Like this is a dummy thing we're doing right now, so I won't be choosing a license, or I won't be creating a git ignore template. But yeah, you can definitely look those things up. Generally I think we use the MIT license. Yeah, MIT I think is for open source development, like anyone can use my work and can basically support me, collaborate with me in this project. Okay, so let's create a repo now. Okay, so the repo has been created. Now it tells me quick setup if you have done this kind of thing before. Okay, so there are two ways by which I can connect my local folder to my remote folder or my remote repo. So this is my remote repo, this is what you're seeing on your screen, and this is my local folder. What we want is for these two to be always in sync. Like we want, if I make a change on my local, that should reflect in the remote, and if I make a change on the remote, that should reflect in my local. So there are two ways of connecting this local folder with the remote folder, like either using the HTTPS protocol or the SSH protocol. Now you can use any one, it's your personal choice, but if you need a more secure connection, I would recommend you to use the SSH one. So now basically I won't be diving deep into what SSH and all is. It's basically secure shell protocol. But okay, so what happens is let's come here again. Okay, so in SSH I'll basically give you a brief overview. So what happens is your system, like basically why do I need HTTPS or SSH to do all this? So basically what happens is this is a remote repository, okay, and this is a local repository. Now if I make a change in the local and I push that change to the remote, how will GitHub verify that I have the authority to push changes to this remote repo? Because there needs to be a way to, like for example, there are 10 people in the world who create this GitHub folder and they push changes to this exact remote repository. So how will GitHub authenticate or authorize people as to which particular person can push changes here and which person cannot? So for those use cases you have things like HTTPS and SSH. So I'll tell you about SSH. What happens in SSH is that your local system has two SSH keys, okay. Mainly you have a public key and you have a private key, okay. You generate those keys in your local system, store them in your local system, then you provide GitHub with the public key. Obviously the name suggests, you remember this, you can never provide anyone with your private key. That is private to you. Your public key is public, you can provide it to anyone. So you provide GitHub with your public key, okay, and using that public key, whenever you push a change from your local to this GitHub repo, Git will verify your identity using these public and private keys. Okay, so how it does that, that is something I don't think lies in the scope of this video, but remember this, that using the public and private keys, like it's not just GitHub, there are a ton of applications of SSH, like the servers that are running at the moment. You don't see people going to data centers and making changes to code bases. For example, you have servers in the US which are running Netflix. You don't have people moving to the data center and making changes in the code. They make changes in their local, and then via SSH they communicate that those changes to the servers. So you provide your public SSH key to GitHub and your private SSH key stays with you in your local. So GitHub authenticates or authorizes you. Okay, so in a very short words, if I have to tell you, basically you have a problem statement or a puzzle which gets created using your public key. GitHub sends that puzzle over to your system, and that puzzle can only be solved using your private key. Since you have the private key on your system solves that puzzle, returns the output. GitHub matches it with the output it wanted. If it matches, it authenticates you, it authorizes you, you are good to make changes in the remote repo. Okay, so this is how it works. So this is how the public private key thing works in SSH. Okay, so if you see for example, this is where you can add new keys. Okay, so how do I get here? Basically you click your profile icon, go to settings and go to SSH and GPG keys. Okay, so basically I have 3 SSH keys. Okay, so basically for different systems you can, obviously every system will have unique public and private keys. No two keys can be the same. Okay, that defeats the whole purpose. So yeah, just a second. Okay, so this is where you can add your SSH keys. Now to add SSH keys, obviously you need to generate a pair, a public and a private key. So I already have it for my system, but yeah, we can do it again. So GitHub provides a very systematic documentation about how to do these things. Okay, so to okay, you have things like which platform you're working on. If you're, in your case, you're working on Windows, you can use that, but like for my case I'm on Linux. So to generate a key, you just have to use the ssh keygen command. So what it does is ssh keygen, like the name itself suggests, ssh generate key. Okay, so okay, now this thing which you are seeing, ed25519, this is the name of the key that you're going to generate. Okay, so this can be anything. Then -c your email @example.com. Okay, so this is you get this now, that every person's email in this world is different, is unique, and every person's phone number in this world is unique. That is why you see technologies like UPI taking advantage of this, and your UPI ID is unique because you have your phone number @ OKHDFC or OKICICI. So that OKHDFC or OKICICI part is common for everyone, but the initial thing, your phone number or your email, like for example GPay uses your email, so, and Paytm uses your phone number. So basically they're using this specific information which is unique to you to create a ID for you. Similarly, in our case, we use our email to create a unique key for us. So if I enter in my email code.latrino@gmail.com, this is only I in the world have this email. So the key that will be generated, the key pair that will be generated using this will be unique. Okay, so if I press enter now, oh sorry, my bad, copy, Control-Shift-V, yeah. So let me enter that again. Yeah, so like this, obviously I think I did not mention this -t is the type of the key you are going to generate. So yeah, you don't want to be changing that. Okay, generating public private key pair, like this is the type key pair. Enter file in which you want to save the key. So like this should be good to go. So just press enter. Okay, now I already had a key generated. Now it asks me, do I want to overwrite this key? So I'll go with yes. If you're creating a key for the first time, it won't ask you things like overwriting, it will directly create the key for you. Enter a paraphrase. Okay, so what is a paraphrase? So whenever you're using your key or you're accessing your key, okay, so because at some time I will have to access my public key and give it to GitHub. Now I don't want anyone who is using my laptop to access my SSH keys. So this paraphrase is just to protect your keys, SSH keys, from anyone who's accessing your system. So just type in a paraphrase, like I have actually typed it. It does not show that I have typed it, but I have typed it, and press enter. Now type it again, enter. Okay, so the keys random art image is this. Okay, so this is just something that you will see every time you generate a key. Now your public and private key has been generated. Okay, so now we are done with this. Okay, so basically every system has an SSH agent. What is the purpose of this SSH agent? This SSH agent keeps a track and manages your keys. So now I'll be giving my public key to GitHub. Okay, so since I'm giving my public key to GitHub, whenever I commit or push a change to GitHub, GitHub is going to authorize, like this person has this public key and this person has this private key. So to do that, you use something like an SSH agent which manages your keys and basically acts as a bridge between two services that are communicating using your SSH keys. So we're going to add our key to the SSH agent. So to do that, I'll just use this command, SSH add my key, enter paraphrase. Okay, so now here you see the use of the paraphrase. Had I not have had access to those keys, I would not have known the paraphrase, and I would not have been able to add my keys to the SSH agent. By the way, you might have noticed anywhere I use these SSH commands, you see this this wiggly hyphen, then .ssh/id, and this. So basically this is the location of where your keys are stored. You can literally just move in and see, like this squiggly line represents your home folder, then /.ssh is the folder, and slash these are the keys. Okay, so like as you can see here, we have this thing id underscore ed 25519. This is your private key. This thing which has a dot pub attached after it is a public key, and then there are other things. So okay, so this is your private key, this is your public key. Remember, never share your private key with anyone. Always share your public key whenever you want to. Okay, so now we have added our key to the SSH agent. Now I think we have generated a key, we have added it to the SSH agent. Okay, so now adding a key to GitHub is pretty simple. Okay, so just what you need to do. Okay, so this is our public key. Okay, so we want to basically access this key. What we're gonna type is, we're gonna type cat home /.ssh, sorry, SSH, and here I'm gonna type id. Now okay, I don't want to access my private key, I want to access my public key. Okay, so I click enter and I see something like this. Okay, so the type of the key, some random strings and numbers, and finally at the end you have my email. So by adding your, okay, so it's not that if you don't add your email, it won't be able to generate a unique key. Obviously, since there are so many random and unique combinations of characters and numbers available, it will still be able to generate a unique key. But adding this email thing ensures an extra layer of security and personalization that this key is yours, and helps in identifying this key as a unique thing. Because even if, let's assume, anyone in the world has this whole thing same as you, his public key is exactly same as your public key till here, but then this part obviously can't be same because different people in the world have different email IDs. So that would be the differentiating point. So this adds an extra layer of security and also helps with you having a personalized experience with your key. Okay, so now we're gonna copy this, come over to GitHub, and okay, so I'm going to delete this key. Click here, new SSH key, add a title for this key. So my title would be Debian. This is the operating system I'm using. Hypercool is the name of my user, and SSH key, it can be literally anything, no restrictions. Paste the key here. Okay, so like I'm able to show this key to you in the video because this is my public key. The name suggests that it's a public key. Beware, do not ever share your private key with anyone. Okay, like don't even access your private key if it's not that urgent. So yeah, this is my public key. Now add SSH key. Okay, so now you can see Debian Hypercool SSH key has been added. Added on 8th November, never used, and the permissions that this key has are read and write. SHA-256 is basically the protocol it is using for encoding and decoding. Okay, that is something that is beyond the scope of this video. Now we have added the key to the SSH agent. I don't think there is anything else that we need to do in terms of SSH keys. Just gonna go back. Okay, so basically check for existing keys, generate a new key, add it to the SSH agent, add that key you generated, the public key, to the GitHub account, and now we are good to go. We are good to basically make changes here. So as you might have seen here, quick setup. Now when I click on HTTPS, it gives me a URL. When I click on SSH, it gives me a URL. So we have used SSH to connect we have chosen SSH as the way to connect our local repo and our remote repo. We are going to click on SSH and basically copy this. Okay, and here it lists
series of steps you are going to follow. To be very honest, if you look carefully, we have followed these steps earlier. Git init, we initialized a local Git repo, we added a readme, we made a commit. Git branch m master. This basically this command is used to create a new branch. And similarly, if I type git checkout this particular branch, I can move into that branch as well. Since we already have a master branch, for our case it is not required. Even if we do this, it won't like have any effect. Okay, so master is not. Oh wait, what? Oh sorry, what? I had to git branch master. Okay, so you can see like nothing happened. We already have a master branch. Okay, so yeah. The next important command here is git remote add origin and this URL. Okay, so if you can notice this URL that you see, git@github.com // this git is the same as this, and this is basically the URL of my remote repository. So what is this command doing for us? Okay, so this command is telling my local git repo that whenever you push a change, you are going to push it to this URL. Okay, so if we break down this command, git is basically the technology we are using. Remote means I am adding a URL that refers to a remote repository. Add URL. Origin is basically a name that I have given to this remote repository. Okay, so whenever I refer to origin, it means I am referring to this particular URL. Okay, and you will see in a while why this helps. I can name it anything, but why naming my URL here as origin helps. Okay, so just press enter. Git remote add origin this URL. Now basically my local knows that whenever I am pushing a change, I'll be pushing that change to this URL. Okay, and finally now git push u origin master. So what does this mean? Let's copy it first. Now I made changes in my local, I added those changes, I staged those changes, I committed those changes. I told you what adding means. Adding means to stage a change. What committing means to take a snapshot of that change and log it into your history. What does push mean? Push means now push that change from my local, that is the folder that is present here, to GitHub, that is the remote repository. Okay, so if you see, we are typing git push. Okay, so push changes. -u basically means upstream, so it means that I am pushing this change to a remote repo, and even if you omit this -u, it is not an issue. It's just used for the first time when I am pushing a change. So when I am pushing a change for the very first time, I will be using -u. After that, whenever I am pushing a change, I don't need to basically use this -u. Okay, so after that, origin. So I told you naming this URL was a good thing, because had you not named it, you would have to type out the whole URL every time. So since we named this URL as origin, we are asking it to push the changes to origin, that is the remote repo. And master, what does this mean? Master means to push the changes to the master branch. Okay, because the remote repo can also have various branches. So push the changes to origin, the remote repo, in the master branch. Okay, now if I by the way, this is a set of hierarchy that you need to follow. Like for example, you can't push something that you haven't committed, and you can't commit something that you haven't staged. So always remember, first of all there will be a change, then you will stage that change. How? Using the git add command. Then you will commit that change, then you will push that change. Okay, remember this this particular series of steps. So now if I push origin master, so as you can see, enumerating objects, counting objects, it compresses them, compressing objects 4 of 4, writing objects. Finally, to github.com. So basically to this remote URL, we have pushed these changes. What does this mean? I have pushed changes from master branch in local to master branch in remote. Branch master set to track origin slash master. Basically this means that your local master will now track any changes that are being made in the remote repos master branch. Okay, so basically you can create a mapping like this. So if you have a, for example, in our case we had master. For example, in the future we create a new branch named V1, version 1 in our local. So similarly we can create a new branch in the remote as well, V1. So basically my local slash V1 will then track my origin slash V1. Okay, so this is how it works. It's a mapping. Okay, now the moment of truth. If I refresh this, you can see we have a tut.txt file. So we were successful in pushing our changes to from Git to GitHub, from our local to GitHub. If you even open this file, you will see what we wrote. Hi there everyone with 3 exclamation marks. Hope to see you all soon. Okay. Now, for like once again, I'll try to like just go through the whole process once more. Okay. So what I'll be doing is I'll be renaming this tut.txt to readme.md. Okay. So readme.md is a pretty important file that you'll see when you visit any GitHub repo. So basically what it does is if you name a file as readme.md, .md is basically markdown file extension. Whatever is in that file is displayed here as a description of that file. Okay, so and obviously renaming a file is also a change, so we'll have to push that change. Don't always think you have to push files to GitHub, you have to push changes to GitHub. Okay, so if I go here now and I okay, so we are going to rename the file, right? So if I go into my local, where do we have, yeah, this one, I come here and I rename this. Okay, so let's rename this file readme.md. okay, renamed. Okay, done. Now listen very carefully. Now I'll be repeating all the steps that we took till now. Okay, so whenever a change is made, what is the first step that we're gonna do? We are gonna type git status to basically take a look at what the changes were that were made. So what do we get here? We have a change, we have basically deleted. Okay, so this is a smart way that Git uses. So what we did in reality was we renamed tut.txt to readme.md, but Git reflects it as we deleted tut.txt altogether and created a new file readme.md with the same contents. It's the same thing. Okay, so it tells me that there is an untracked file readme.md. So if it's untracked, if it's unstaged, what are we gonna do? We're gonna do git add dot. If I again go to git status, now this file has been added to the staging area and it's ready to be committed. So now we are gonna commit this file. So git commit and modified file, no, created new file readme.md. Oh, you can also type modified, you can like type anything you want. Basically it should be something helpful. You can also type modified tut.txt to readme.md, or you can type renamed tut.txt file to readme.md. It's your choice. The message is completely your choice. Okay, so commit this. Okay, so we have so you can see 0 insertions, 0 deletions, because we did not make any changes inside the files. This insertions and deletions thing is just that's something that tracks the lines of code that we are changing. Okay, so we changed one file but did not make any changes inside the file, did not delete any line, did not add any line. Okay, we have now committed the change. Does the change reflect here? No, obviously not, because we need to push that change. So we're gonna type git push origin. Okay, so basically let's do this. The technology we're using, git. What do we wanna do? Push the changes. Where? Origin. Where inside origin? The master branch. Okay,
Now let's give it some time, and done. So now if I refresh this, the moment of truth, here we go, we have a readme.md file instead of a tut.txt file, and just like I told you, whatever is in the readme.md file will be shown out here. Okay, so that is basically a protocol that GitHub follows. Now I think we are done with most things. One more thing that we'll be covering is any change made in the remote needs to be reflected in my local as well. Okay, so now you might be asking, why would I make changes in the remote? So you won't be explicitly going here making changes, but there can be a ton of people collaborating in your project. Okay, so if someone makes a change in California in their local and pushes those changes in this remote repo, now obviously you need to pull those changes in your local to be able to work with them. Okay, because to run code you need that code in your local. Okay, so if someone pushed changes from California into the remote repo, you need to pull those changes. So let's, for example, make a change, add a file, create a new file. Okay, let's name this file requirements.txt, and let's type something, Python, SQL, Excel, Spark, Tableau, Databricks, GCP, Azure, like it's just random stuff I'm typing out, Java. Okay, so now by the way, you can directly commit changes if you're in GitHub. Obviously, like directly just commit changes, no need to basically add changes or push changes. You get the sense now, because we are in the remote, so we don't need to push changes. So just commit message, created file requirements.txt. you can type a description, who is the commit email basically. Okay, also we also need to talk about this, I'll come to that in a few minutes. Commit directly to master branch or create a new branch. Okay, so this is your choice, commit to this branch or create a new branch and commit those changes there. Okay, so commit changes, I am committing to master obviously. So now you can see in the remote we have a readme file and a requirements.txt file, but in our local we only have a readme.md file. So how do we get this requirements.txt file, because we need the changes in the remote in our local also. So we'll simply do git pull origin. Okay, so once again, the technology we're using, git, what do we want to do? Pull. What do we want to, from where do we want to pull? Origin. From where in origin? Master. Git pull origin master. It pulls some changes, 9++ insertions. Now if you look at your directory, we have a requirements.txt file. Okay, with the same contents. Okay, so this is how you pull changes from the remote into your local. Another thing, you will see some places you will see pull, some places you will see things like fetch or merge. So it is the same thing basically. What I'll tell you what fetch or merge is. Like instead of git pull, you can also do git fetch, git merge, git rebase. Okay, things like that. What do they mean? So basically, pull makes things easier for us. It directly tells git to pull changes from the remote repo and integrate them into my local repo. If we use fetch, what fetch does is it will pull changes from the remote repo but will not integrate them into my local. It will just pull the changes. It will tell me these are the changes that have been made into the remote repo. After fetching, I can do git merge and it will basically merge those changes that were made in the remote to my local system. Okay, so basically if you are using this this route, so first you'll need to do git fetch, then you'll need to do git merge, but an easier way is obviously git pull. It's basically a combination of git fetch and git merge, so you don't have to type two commands, you just need a single command and you're good to go. Okay, so that's about pull, git pull. And yeah,
I talked about, like, so you saw now, like every commit that so when we were committing in the local, you saw that it asked me for the email, like which particular email is committing. And if you're using Git for the first time, when you will be on this step, like when you will be committing for the very first time, or you'll be staging for the very first time. I think when you'll be committing, not staging, when you'll be committing for the very first time, like my system is old, I have committed a lot of times, but when you'll be committing for the first time, it will ask you for a email and a username. Okay, so why does it do that? So and I'll also provide you with the commands. Okay, so like no need to worry, it will basically, it's something like git I think it's git config user dot email, and here you type in your email and something like that. Okay, so and for user it's something the user dot name. Okay, and here you type your name. So like don't worry, it will tell you to add your, like in the terminal only, it will tell you to add your email and your username, and it will give you the commands also, like the commands you need to use to do that. Okay, so why is it doing that? So any commit, if I come back to my code after 20 years or 20 days, I told you that every commit has a message, and what is the purpose of that message? To basically describe what the commit was all about, so basically describe the changes that were being made, but you also need to keep a track of who made those changes. Okay, so that author thing is something that is very important for a commit. So that's why you need a author, basically a user email or a user name to a particular commit. If I type git log, so git log is nothing, git log is a log that keeps a log of all the commits that were made in this repo. So if you see, our first commit, if you remember, was created a file tut.txt, then we modified file tut.txt, then we created a new file readme.md. Actually we renamed tut.txt to readme.md, but GitHub interprets, but Git interprets it as we are just removing this tut.txt and creating a new readme.md. And finally created requirements.txt. If you remember, requirements.txt was not created in the local, it was created in the remote, but still we are able to see that commit here. So this is like the beauty of Git. So the perfect integration between the local and the remote is so seamless that you will not even feel. Okay, here you can see head origin, head master, origin master. What does this mean? Okay, so basically what is head? So head is a point, it is basically a pointer that points to as to till where has Git tracked my changes in a repo. Okay, so right now Git is the head is pointing to the latest commit. If you can notice, the first commit was this, then this was the first commit, then this was the second, and this was the third. So my commits are moving in this order, like from bottom to top. Okay, so and you can even see the time at which they were committed. Okay, and the time zone and all. And see, here I told you the username and the email. Okay, so this is very important because you need to know which person committed this change, which person committed this change when, and what was the change all about. This is where the message is reflected. Okay, so right now the head is pointing to this particular what do I call it, commit. Okay, there can be times when you commit when you don't want the head to point to this particular commit. For example, if you're reverting back changes, you want I want my repo to be what it looked like on November 8, 3:12 p.m. Okay, so to do that you will revert back to this commit, and that is where this commit ID will be very useful. Okay, so basically wherever this head points, that is where your current state of the Git folder is all about. Okay, so this head pointing to something represents the current state of your Git folder. By the way, this master and origin master also you might get it. Head is currently pointing to this commit inside this master branch, that is the local branch, and also in my remote repository it's pointing to origin/master. Okay, see here you can see
master. I can create new branches here. I can even create new branches in my local and all. Okay, so that is what it was all about. So this is like something you need to know. This is how commits work. Okay, and you can basically cherry pick. There's something called cherry picking also. You can literally cherry pick which particular things you want to revert back to or point back to and things like that. Now there's one thing we should see. Git branches, go to images. Okay, so some people confuse branches with different folders within the same folder. That is not how it works. And also, by the way, Git stores all the branches, all the information about various branches, all the commits, everything inside this .git folder. So you should not basically meddle with this folder. It's a pretty important folder. Okay, so let's look at a good example here. Okay, so a branch is not a new folder. For example, if I make a change, okay, my file was, I had a GitHub repo, master branch, pointing to origin/master, both are synced. Okay, both are at the same level. Now I make a change and I add that change, I commit that change, alright, but I don't push it to origin master. I push it to origin/v1, origin/version 1. So master will, wait, I should use this. Okay, so I made change 1. Change 1, okay, I made the change in master, like my wait, not master, I should type local/master, and I pushed those changes in, origin.master. okay, basically my remote. Now I make another change 02. Where do I make this change? I make this change in my local/v1. I create a new branch and I push that change here. I push it to origin/v1. Now basically I made a change. This change can be anything, a line of code. Okay, GitHub will, okay, so we have one file. Okay, let that file be tut dot whatever, like cpp. Okay, so this file is present in origin/master also. This file is present in origin/v1 also. But you will notice that the version of this file that is present in origin/master will have only one change, this one, and the version of the file of this tut.cpp that is present in origin/v1, that will have this change O1 and this change O2 as well. So basically, if for example the first change was name is equal to Priyam, okay, this was the first change, C1, and second change was email is equal to whatever, okay, this was C2. So the first file is going to look something like this. First file is going to look like name is equal to Priyam. That's all. Okay, this is what the first file is going to look like. Like the tut.cpp is going to look like inside origin/master. This is what tut/cpp is going to look like inside origin/v1. Okay, so it's the same file. People think it's two different. It's not two different files. It's the same file. It's just that this file has a different version in v1 and a different version in master. Okay, so branches are not different folders that we are creating. They're just different points in time where that file has been tracked. Okay, so this I think can be a good example. So like we had a main branch and we were up to date, version 1.10. Now something breaks out of the blue, something breaks in your code or in your app. What do? You do a hotfix. Okay, create a new branch. Why would you not fix that thing in master? Because you don't want to be messing with the master branch, the master, or which are also called the main branch. So you don't want to be messing with the master or the main branch, because you need to have some place where you have the original code. Okay, because if something goes wrong, you try to you try to fix a bug and you create more bugs, then how are you gonna revert back? So you need one line or one version line to be perfectly is clear. Okay, so this looks something like, if you might have seen Loki and all, you have different timelines and all, so this looks something like that. Okay, so for hotfix, you create a new branch. So this transition that you're seeing from blue to red, we created a new branch, made changes, tested the code. Okay, so in this, for this example, basically this was that something that was in main, created a new branch, made changes. So this is something that is in hotfix branch, made changes, tested the code out, ran the code, worked fine, merged this hotfix branch with main. Okay, so basically you can merge branches also, because like when this is tried and tested, works, you just merge them. Okay, so when you will merge them, the changes that were present in hotfix, they will be integrated into the changes that were present into master. So then what will happen is, this will be deleted, only one version of this file will be present inside origin/master, and this v1 branch will be removed. Okay, it will like you can keep the branch if you want, but like master will basically be up to date with v1. Okay, so master and v1 will be up to date, and then master will also see, you will also see change to reflected in master. Okay, but only once you have tried and tested the code in this other branch. When you are done, they are tried and tested and the code works, merge these changes that were in v1 to master, and then both will be at the same level. Okay, and like you can even see this literally happening when one branch is not at par with the other, with another branch. You can see something like this branch is 2 commits behind that branch or something like that. Okay, so that is how it works. Now see, if you look here, basically this project has a branch called main hotfix. Hotfix is used for quickly fixing changes, release, dev, and feature. Now dev, okay, so we made a hotfix. When we made a hotfix, now hotfix was updated. So our dev branch earlier was at par with our main branch. We merged this fix into the main branch, and since we have fixed it, we can now call it version 1.0.1, and we can also integrate that same hotfix into the dev branch, because you need to have a separate dev branch and a separate main branch. Now this version 1.0.1 and this particular circle in dev, they're at the same level. Now you keep moving forward in time. Now you need to release release the app, for example. So what you will do, you have a new branch, just okay, by the way, we missed this also. So till here main and dev were at par with each other. Now you need to add a new feature. So features are, you can't just basically start editing this dev only. You need to create a new branch. Always remember, if something can break the code, you need to create a new branch for it. Okay, that's the whole purpose of GitHub. So create a new branch feature, make changes. This transition basically represents that we are making a change. We made a change here, and by the way, we already knew hotfix had been integrated into dev. This branch keeps moving. This dev branch keeps moving. Now this has the hotfix, this has the hotfix, this also has the hotfix. Feature was ready, tried and tested, integrated into dev. Okay, so now it was merged. So this particular circle has both feature and hotfix. This on the other hand only has hotfix. Okay, getting what I am saying? Now we are up to this point. Now we need to release it, release a package or release a application or something. Create a new branch, release it. For example, we had to make some tweaks in the release. So no need to basically meddle with dev or feature or main or hotfix. Just make changes in release. Okay, now you made changes into release, merge those changes into dev, merge those changes into main. Okay, so try to remember, main and dev always need to be at par with each other, and they are the parent branches. They need to have all features that were present. So now you might be thinking, does this version 1.0.2 have everything? Yes. How? Because see, this hotfix thing was already merged into main in version 1.0.1, and so it will obviously be present in version 1.0.2. What about the feature? The feature was merged into the dev. Okay, I get it, it was not merged into main, but if you see carefully, this feature was merged into dev. We created a new branch called release and then merged that release branch into main. So automatically this feature will be present in this particular version of the main branch. Okay, so talking about this circle, does this have everything? Yes, it has everything, because we had hotfix was integrated into or merged into dev. Then we had a feature that was also integrated into dev. Then we had a release, we made some changes, and that also was integrated into dev. So this dev also has the hotfix, the feature, and the changes that were made in release. Okay, so this is how branching works. Branching is not a different folder, it is just how Git tracks folders. Okay, so it's just how Git tracks changes. So you can have the same file with two different versions in different branches. Okay, now finally at the end, let's just look at some random, let's explore some random remote repos to get an idea of how things work. So I think, can we look at this? Yeah, exactly. So these are all the files that are available inside this GitHub remote repo. This is the description that I was talking about. These are all the stats. These are the releases, by the way. These are the contributors. So see, in real life there are so many contributors, 116 people contributing to the same remote repo. So that's the beauty of GitHub. Everyone can seamlessly integrate their code, test their code, run their code, merge their code with the main branch seamlessly. Okay, and by the way, I told you whatever's in readme.md, that is represented here. So yeah, this is what the person wants to describe about his repo. It's a pretty good and neat documentation which every repo should have. This is the license he's using, Apache 2.0 license. You can read through what this means. Basically it relates to things like copyright and other things. If you look here, we have 7 branches. So this particular repo has 7 branches, and every branch should have a name that represents what that particular branch is trying to achieve. So here we have main, brights, create, pull, request / patch. So you can have a branch for patches. You don't want to patch code directly into the main. You want to first test them out. If they work fine, then merge them into main. We have foo, we have release please branches main. So for release you have a different branch. We saw that release please branches main component. So okay, so it depends on the author. What you saw in the example that we were seeing right now in the image, that was a very perfect example of how software actually works in the dev space. And this person, since it's a personal project and all, he has tried, but yeah, it's a pretty good naming convention, you can say, to the various branches he's providing. Okay, so that's all I would like to say, that this is all that we need to talk about in this video. And you can literally search for stuff like Firefox GitHub, Mozilla GitHub, because you see now anything that is open source, like for example VLC media player or Firefox browser or OBS Studio. So all these things are available to, since they're open source, they're publicly available to people. And where are they available to? In GitHub. People can literally contribute. You can fix things, and you should try doing those. That can help you get an intuition. So you can literally fix things. You can okay, so you might have heard of things like PR. So what happens is, you need to make for example, you see that something's not right in the Firefox browser, you move to their GitHub repo, you fork their repository. Okay, so wait, so for example, this is a repo. Forking a repo means to basically take this repo inside your GitHub account. Okay, you can't directly start working here. So if I click on fork, to fork your own copy of this particular repo in your personal account. You can fork it there, clone it to your local. Clone it to your local means basically get the files in your local system. How do you do that? Basically just git clone and this URL, or you can use SSH, or you can literally download the zip and all. Make changes, run it in your local system, stage those changes, commit those changes, push those changes. Now where are you pushing to? The fork that you had created in your personal account. Now as soon as you push a change, GitHub will tell you that this fork that you have created is not at par or not matching with this one. Obviously it won't, because you have made changes. What you can do is, now you can create a PR, you can create a pull request. So what a pull request is? A pull request is that you're asking the author of this repository, this Firefox, this pdf.js project, to basically integrate the changes that you have made in your fork of this repo into this main repo. So basically what he'll do is he'll run your changes, he'll review your changes, and if he finds them good enough, he'll basically pull those changes that are available in your fork of this repository into this main repo. Okay, so that's how pull requests and all things like that work. So like you can look those things up, but I think right now for a basic overview of GitHub, this is enough. So yeah, I guess we are pretty good to go and start creating repositories and playing around with them. Like you saw, creating a repo was pretty easy. Just create a repo, play around with it, and yeah, explore stuff. And bye.